Hello, this is Mark O'Brien from Scalyr, and I'd like to demonstrate a common troubleshooting exercise to show you how easy it is to work with Scalyr. But first, I'd like to talk a little bit about our architecture and what makes us different from other solutions on the market. When we went to build Scalyr, we knew we wanted something that would operate very well at scale and also return results very fast, allowing you to get from alerts to answers quickly. Our initial focus for Scalyr was log management, and in 2020 we introduced the Event Data Cloud, which leverages our technology to work with different event data streams. This data can come from a range of sources, piped through a variety of ingestion mechanisms. You can then use the Scalyr UI for querying and visualizing this data, or pull it into other tools like Grafana or Google Data Studio. To deliver on this promise, Scalyr invested heavily in optimizing along three axes: scale, performance, and cost. Scalyr is capable of ingesting hundreds of terabytes per customer per day and returning results quickly, with unit economics unparalleled in the industry. One way we differentiate is by virtue of the way we store data. We looked at our competitors who are all using keyword index-based solutions. When their data is coming in, they build and maintain a keyword index which can then be used at the time of search to reference where certain words or tokens appear in the dataset. This approach works great for web search. It works great when you need to show the top 10 matches and when you're working with human language corpus, largish documents. This is great for data that doesn't change really fast, but none of these things really match the event data use case. Instead, what we need to be able to do is work both with real-time data as it comes in, as well as look back on historical data. We need real-time ingestion so that data is accessible to us as fast as possible for alerting and tailing and troubleshooting. We want to make sure this performs well at scale, and of course, we're working with machine-generated data, so it's not just English words, for example, it's all kinds of combinations of letters and numbers and characters. This is data with very high cardinality. None of these things are really well suited for a keyword index. So instead, we built our own columnar database specifically for this purpose. The idea is that as we ingest data, we parse it into columns or discrete fields, essentially. These fields get stored together on disk. What we're looking at here in this example is web server log lines, and I've got all my IP address, the timestamp, actions, etc. So if I want to search specifically on IP address, I'm only going to search this particular column. I don't have to search my entire data set. Log data in particular can be messy, and one of the great things about Scalyr is that you do not need to define your schema in advance. The structure we're looking at here does offer better performance, but we do also support free text search, including regular expressions. So this is one part of our architecture, and this is combined with a massively parallel search solution. Scalyr is delivered as a hosted service. We leverage the economies of our scale as a vendor to be able to provide you with an incredible amount of compute power when it comes time to do a search. Your data is sharded among multiple servers, and all of those servers participate in returning search results. We are able to provide you a huge amount of compute power at a cost-effective rate because these servers are shared amongst all of our customers. What we're looking at here is an overview as you enter a sample Scalyr account. We've got a Kubernetes cluster with a number of deployments. We've also got a simple e-commerce web app running with some app servers, image servers, MySQL servers, web servers, etc. We've got a cluster, 26 hosts, 1,130 logs. This account ingests about 1.7 billion log lines each month. So this is an account with a fair amount of scale. Just want to give you that frame of reference as we move through and you see how fast and responsive the system is. We've got a very robust alerting system. For troubleshooting, this is one way that you would become aware of an issue that needs your attention. We allow you to set triggers and you can send alerts via email, Slack, PagerDuty, OpsGenie, etc. And we also have a webhook integration for other systems. So let's say I'm concerned about my response time, and I've got an alert here that's set to look for pages that take more than 7.5 seconds to load. So if in a 2-minute period I count more than 2 instances of that happening, I'll fire off the alert. And from here I can also link over to search and see how often this is happening. If I want to rope in some other folks to take a look at this, I can share this, I can post a graph to Slack, I can also copy a link and send it to my colleagues. Another way to come into the tool when you're troubleshooting is via a dashboard. What we have here is a web server dashboard that gives me a heads-up display on a number of different metrics around my web servers. And similar to the alert, I'm looking here at the response time. I can zoom in and look specifically at the 99th percentile performance of my response time. And I'm seeing these spikes of slow performance. But the beauty of these graphs is that they're backed by log lines. So I can have very easy access to the log lines that are behind the graph. And what I'm looking at here are web server access logs. We've parsed out a number of attributes So I can look here and see what server hosts are involved. I can look at my response time, my time MS. From here, if I click this button to graph values, this is going to take me back to the graph I was at before. I can also get a histogram here. I can click on the distribution button and I can see how these values are distributed. And I can see that the vast majority of my responses are coming in less than 5 milliseconds. But there is this long tail, and as I scroll over here, you can see I'm even getting some responses that are taking 10, 15 seconds. If I flip back over to the log lines here, I have the ability to narrow down. So for example, I can click on page and narrow down to friends, and you'll see that I'm building out a search query here in the search bar. But I can also type the query myself. So if I want to zoom in and just look at those response times that are greater than 7.5 seconds, I can enter that query here. We automatically recognize numeric fields, so we're very fast at searching for ranges. So now I've got my query, I'm looking at my slow performing transactions, and you can see they're happening in bursts. Also within the log lines, you can see there are a number of fields available to me. If I click on one, I can get a drawer that pops out and shows me in detail each line, and I can click around to see the different lines. I can also then close by clicking again. One of the fields that's available here is the request ID. This request ID is provided by the web application, and it's unique to each transaction. A lot of applications do something like this. It's great with microservices, also e-commerce, where you want to track a transaction from start to finish. Scalyr has a feature called Smart Links that lets me build a hyperlink based on the contents of a log line or a field. And in this case, I'm linking to another Scalyr search, but I could instead link to an external service, for example, to look up a user in a customer database, etc. But clicking on this link does a new search for this request ID. And what you'll see here is that I get a list of the logs that are related to this particular transaction. So this is a lot like a trace. It starts here at the web server, goes back to the app server, which makes a MySQL call, then comes back to the web server and returns the response to the user. As I'm scanning through here, you can see I've got this warning, invalid cache detected, and I wonder what this is. So let's see how common this particular error is occurring. Is it unique to this transaction? Is it unique to one server? Look, what's going on? If I highlight this text, I have some options. I'm going to do a new search, which essentially just does a search specifically for this text, and lo and behold, I can see it's happening a lot. It seems to be happening in the same pattern. We've got these bursts. And then when I look at the server hosts, I can see it is affecting all of them to some extent. So this is most likely some kind of a database issue. But basically, very quickly, through just a handful of searches, mostly using the mouse, I've been able to pivot through my data and get down from a visualization, seeing these slow transactions, leaping right into this level of detail where I can see this particular error. And now I've got a lot to chase down, either with myself or I can share with my colleagues. I could save this as a saved search. I could also share it by copying a link to this search and sending it to them. There's one more example I'd like to show here. This gives you another indication of the flexibility of our graphing functionality. So a view here I have is of my response bandwidth. A wise engineer once said, bandwidth costs money, so you may want to pay attention to this and see what you're spending money on. And one thing I can do here is, so this is a representation of all of the bytes that are coming through my web server. If I want to slice this down, if I want to divide it up by URI path and do a breakdown graph, what I can see here is I've got a couple of URI paths that are head and shoulders above the other ones. And if I look over here, you can see it's the image render and image paths. Well, maybe not too surprising that the image paths are going to be using more bandwidth, but this does give me an idea of perhaps some low-hanging fruit, things I can look at to optimize, perhaps add some compression, etc., but other ways to try and address bandwidth. So those are just a couple of examples of how easy it is to work with Scalyr to get to the answers you need. I hope this has been helpful.